Okay, welcome to Operating Systems Preemptive CPU Scheduling Practice. So let's get started. We will be doing the calculations, so if you need to review, go back to the other videos to review what turnaround time, waiting time, response time, and CPU utilization are. In this case, we will have simple exercises, so the CPU utilization will be 100%. We will be doing the preemptive algorithms, round robin, shortest remaining time, which is shortest job first preemptive, and preemptive priority. So let's get started. Here's our first exercise. This is round robin, which is first come, first serve, only instead of allowing the process to stay on the CPU to complete its entire burst, it will get 5 time units, which has been assigned to your time quantum of 5, and in which case, after it finishes its 5 time units, it will then be preemptive and we'll have to go directly back into the ready queue. So let's get started. This is our Gantt chart. And we start at time 0, and since it's first come, first serve, we will start with P1, which arrived first. And P1 does have a CPU burst of 8, and so it will be given 5 time units on the CPU, and at time 5, it will then be preempted and go back into the ready queue at time 5, and we'll have 3 time units of CPU burst left. Now the current time is 5, and the next one to arrive is P2. And P2 happens to have a very short CPU burst, less than the time quantum, so therefore P2 will complete its execution and will be done at time 8. Now next up, the current time is 8, and the next one to arrive if you look at the arrival times, is P3. And P3 has a CPU burst of 10, so it will go until time 13, and then it will be preempted and need to go back into the ready queue at time 13, and we'll have 5 time units left of CPU burst. And now the current time is 13, and this is where you need to be careful because P1 actually arrived in the ready queue before P4. So you might think, oh, I want to use P4, but P1, because it got there at time 5, that is an earlier arrival time than P4. So therefore the next to go is going to be P1. So P1 will go next, and P1 has 3 time units of CPU burst, and so at time 16, P1 will be done. Okay, now the current time is 16, and in the ready queue we have P3, P4, and P5, and P4 got there at time 6, so P4 is going to go next until time 21, and then P4 will have a new arrival time of 21. Oops, that one's done. And we'll have 4 time units of CPU burst left. Now the current time is 21. So the next one to arrive in the ready queue was P5. And P5 will get 5 time units until time 26. We'll have a new arrival time of 26. I hope you can see that enough. And now the current time is 26, and we have P3, P4, and P5, so now it's pretty simple to just run them in that order. So we would have P3 got there at time 13 and has 5 time units left. P4 has 4 time units left, and P5 has 2 time units left. So the total time it took to complete these processes was 37 time units. And since we have 100% CPU utilization, then we if you add up all the CPU bursts, then that should equal to 37, which I checked and it does. Okay, so now we need to do the calculation. So let's start with the response time. So the response time is a one-time measure from the first time they arrive to the first time they get on the CPU. And the response time is also the first measure of wait time. So P1 had arrived at time 0, first got on there at time 0, so P1's response time is 0. Let's do all of P1 and then all of P2. Then to do the turnaround time, you take the last entry, which is right here. P1 finished at time 16, arrived at time 0, so P1's turnaround time is going to be 16. Now you can take the turnaround time and subtract the CPU burst time, and you would get the wait time. So that means that P1 was active in the system for 16 time units. 8 of those time units it was on the CPU, and 8 of those time units it was waiting. And the way to check that is just to check here. P1 waited 0 time units here, but then P1 waited 8 time units here. So keep in mind that the response time is a one-time measure, and it's the first measure of the wait time. So let's check P2 now. P2 arrived at time 3, got there on the CPU at time 5, so response time was 2. P2 was active in the system for a total of 5 time units. So the wait time is going to only be 2 time units. P3 arrived at time 4 and finally got the CPU after waiting 4 time units. So P3 to get here waited 4 time units, and then P3 got preempted and had to wait all this other time units, which was then waited 13 more time units. So P3's wait time is going to be 4 time units plus the additional 13 time units. So P3 waited a total of 17 time units. The other way to get the wait time is just to say P3 finished all of its work. Its total time active in the system was 31 time units. It arrived at time 4, so its turnaround time would be 27. And then if you take that 27 and you subtract, well, out of those 27 time units it was active in the system, 10 of those time units it was on the CPU, then 17 it was waiting. So then we have P4. P4 arrived at time 6 and got to the CPU the first time at time 10. And P4 finished at 35, so was active in the system for 29 time units. And 20 of those time units P4 was waiting. And P5 arrived at time 11 and eventually got to the CPU at time 21, so waited 10 time units. Again, response time is a one-time measure. P5 finished at time 37, so the turnaround time is 26. And the total time that P5 waited was the first 10 time units, and then P5 had to wait again 9 more time units. So if you take these numbers and you add them up and divide by 5, you will get the averages. So let's move on to the next exercise, which is shortest remaining time, or shortest job first preemptive. So in this case, we're going to use 5 processes again, and we'll make our Gantt chart. And this you have to keep track of. If a process is arriving and its CPU burst is shorter than the time that is left on the process that was just executing, then it's going to preempt. So let's get started. So at time 0, we start with P1. Now P1 has a CPU burst of 8 time units. And what's going to happen is at time 3, we're going to have the arrival of P2. And when P2 arrives, it's going to preempt P1 because at time 3, P1 has a CPU burst of 5. At time 3, P1 has 5 time units left of its CPU burst, and P2 has only 3 time units of CPU burst. So P2 is shorter remaining time. So P2 will go next, and P2 is the shortest one here, so it will not get preempted. So P2 will go until time 6. And now the current time is 6, so P2 is done, and we need to make a determination on who goes next. Well, at time 6, in the ready queue, we have P1 that has a CPU burst of 5, we have P3 which has a CPU burst of 10, and we have P4 which has a CPU burst of 9. So if after you do not have any shorter ones arriving, then it just goes and follows along as shortest job first. So we can see by looking at this that we will finish this as shortest job first. So we have P1, which will go until time 11, followed by, now at time 11, they're all there. P5 has also arrived now at time 11, and P5 has the shortest CPU burst. And then we have P4, and then we have P3. And once you get your Gantt chart correct, it's quite simple to calculate the response time, the wait time, and the turnaround time. So P1 arrived at time 0, first got on the CPU at time 0, so P1's response time is 0. P1 turnaround time, if P1 finished at time 11, because it arrived at time 0, and you can see here that P1 had to wait an additional 3 time units, so its wait time is going to start 0 time units when it first waited, plus the 3 additional time units it had to wait. Then P2 arrived at time 3, got the CPU right away, and never waited, and finished at time 6, so was active in the system for 3 time units. P3 arrived at time 4, did not get the CPU until time 27, so its P4's response time is going to be 23, and turnaround time is 33, and it only waited 1 time, so it's 23. P4 arrived at time 6, first got the CPU at time 18, so P4 is going to have a response time of 12, and a turnaround time, finished at 27, arrived at time 6, so a turnaround time of 21, and only waited a total of 12 time units. And P5 arrived at time 11, first got the CPU at time 11, did not wait at all, and was active in the system the 7 time units of its CPU burst. So that's how you do shortest remaining time or shortest job first preemptive. Now we're going to do preemptive priority. Now in this case, in doing preemptive priority, the highest priority is going to be 1. So we need to know that. We need to know that 1 is the highest priority. And if you have to break a tie, you're going to break the tie based on the arrival time, or first come, first serve. And if a lower priority task happens to be on the processor and a higher priority task arrives, it's going to get preempted. So let's see what happens. At time 0, we have P1. And P1 is on the processor. However, if you notice here that P2 is going to arrive at time 3, and therefore at time 3, P1 is going to be preempted and kicked off the CPU because P2 has a higher priority. So when P2 arrives at time 3, it kicks P1 off the CPU. So P1 goes right back into the ready queue at time 3 and has 5 time units left of CPU burst. So now the current time is 3, and the next to go is going to be P2. Okay, so now the current time is 3, and P2 is going to go on the processor at time 3, and it has a CPU burst of 3. So P2 will be done at time 6. So let's just cross that off. All right. So now the current time is 6, and this is priority based, but P5, which is the only other high priority, which has not arrived yet. So we're going to just have to do first come, first serve based on the process that are in the ready queue. And so P1 is going to go because P1 went into the ready queue at time 3. P3 went into the ready queue at time 4, and P4 went into the ready queue at time 6. So P1 is going to go first. Now if you notice that P5 is going to arrive at time 8, and P1's CPU burst is going to go past that time of time 8. So at time 8, P1 is once again going to get preempted and have to go back into the ready queue because it is a lower priority. So it's going to go, P1 will go back into the ready queue at time 8, and we'll still have 3 time units of CPU burst left. So now the current time is 8, and we have the arrival of this high priority here, P5. So P5 is going to go, and we can see by looking at this table here that P5 is the only high priority one left. So P5 is going to finish its entire CPU burst and until time 15. All right, so now the current time is 15. P5 is done, and we have in the ready queue P1, P3, and P4, and they are all priority 2s. So since they're all priority 2s, we will just, and none of them are going to preempt each other, we will now use first come, first serve to complete the rest of this Gantt chart. So we have P3, which will go until time 25, followed by P4. And the reason P4 and P3 go before P1 is because although P1 originally got there at time 3, it got preempted again and went back at time 8. So 4 and 6 are before time 8. So we have P4, which will go until time 34. And then we have P1 to finish off and be done at time 37. All right, so once again, we have 100% CPU utilization. We just have a different order in which the processes execute. So let's calculate the response time and wait time and turnaround time. So P1 arrived at time 0 and first got on the CPU at time 0, so P1's response time is 0. However, P1 completed all of its execution at time 37, so P1's turnaround time is 37. Now, of those 37 time units that P1 was active in the system, only 8 of those time units P1 was actually on the CPU, so P1 actually spent 29 time units waiting. It didn't wait in the beginning because it was the only one there, but it did end up spending 29 time units in the ready queue waiting for the CPU. Now P2 arrived at time 3, got the CPU right away, never waited at all, and was active in the system for a total of 3 time units, all of that time on the CPU. P3 arrived at time 4 and eventually got the CPU at time 11, so P3's response time was 11. P3 finished at time 25, and so P3's turnaround time is going to be 21. And if you take a look, P3 spent 10 time units on the CPU and 11 time units waiting. Then we have P4. P4 arrived at time 6 and eventually got the CPU 19 time units later at time 25. And P4 finished at time 34, so P4 has a turnaround time of 28 time units. And you can see that 19 of those time units P4 spent waiting, and 9 of the time units P4 spent on the CPU. And P5 arrived at time 8, never waited, obviously because it's a priority 1, and this is preemptive priority. And it preempted a priority 2. And so it only spent 7 time units active in the system, and all of those time units it spent while on the CPU. So I hope this helps you to understand these algorithms, and in the next video we will practice multi-level queue and multi-level feedback queue.